Okay, question number 2 uses de Moivre's theorem. De Moivre's theorem is cos theta plus I sine theta to the power n is cos n theta plus I sine n theta. In this case, because we're interested in cos 6 theta, we know that n must be 6. And because we're only interested in the cosine part, we don't want the imaginary part. So what I really want is to do cos theta plus I sine theta to the power 6, and I want the real part. Okay, so I want the real part of that, and that's going to equal cos 6 theta. So if I expand the left hand side, right, I end up with cos theta cos the power 6 theta. The second term I don't want because I'm getting cos the 5 theta times I sine, so it'll be an I component. So I'm looking for even powers, because then the i's will be I squareds, which is minus 1, and so on. So the next one, this is 6c0, 6c1, I don't want 6c2 times cos the 4 theta times I sine theta squared. I don't want 6c3, 6c4. I get cos squared theta I sine theta to the power 4. And finally, there'll be 1 of I sine theta to the power 6, or 6c6 at the beginning if you prefer. Alright, now I'm going to let cos theta equal y, simply because it means I've got a lot less to write down. So I've got y to the power 6, 6c2 is 15, y to the power 4 times minus sine squared, which is minus, so I put the minus here, minus 1 minus y squared. 1 minus cos squared is the sine squared, and I squared is the minus at the beginning. This one is plus 15 cos squared, 1 minus cos squared squared, and I to the power 4 is plus 1, so that's fine. I to the power 6 is minus 1, so it's minus sine to the power 6, which is 1 minus cos squared to the power 3. Okay, now I expand all this out. Alright, so I get y to the power 6 minus 15 y to the power 4 plus 15 y to the power 6. This multiplied out is obviously 1 minus 2y squared plus y to the 4. So I get plus 15 y squared minus 30 y to the power 4 plus 15 to the power y to the power 6. And this multiplied out is just a cubic, so I get minus 1 minus a minus, so plus 3y squared minus 3y to the 4, and then minus, plus y to the power 6. Anyway, tidy that all up, and I get 32. If I just do the y to the 6's, I get 32 y to the 6. Take away 48 y to the power 4 plus 18 y squared minus 1. So therefore I end up with, so that implies, remember this is a real part of this, which I know equals cos 6 theta, so I've got 32 cos the 6 theta, take away 48 cos the 4 theta, plus 18 cos squared theta, take away 1, equals cos the 6 theta. Okay. Not too bad, just a bit of algebra involved there. Now it says hence solve. So we've got to use the fact we've already got what we've got so far. So, so we've got, for part B, it says theta is between pi by 2 and 0. So therefore we know that 6 theta is between 3 pi and 0. Okay, so what am I doing now? So hence solve that. So if we look at what we've got double, apart from a -1 at the end there. So okay, so we've got 2 cos 6 theta would give us everything we want, apart from, it only give us a -2 at the end. I want -3, so minus an extra 1 would equal 0. So if we double the part A, we get it all correct, apart from I need to knock another 1 off in order to be 0. So I get cos 6 theta equals, move the 1 across, divide by the 2. So I get 6 theta is pi by 3, 5 pi by 3, 6 theta, sorry, yep, I often think in degrees to be honest, but 60 degrees. So it's a half, let's be 60 degrees, it will then be almost a complete loop, take away, so it's 2 pi, yep. And then I have to add on 2 pi for this, so it's 7 pi by 3, and so on. 7 pi by 3 is less than 3 pi, so that's good. The next one along would be this plus 2 pi, which would be too big. So theta is pi by 18, 5 pi by 18, and 7 pi by 18. And complete.